Slope. The slope of a line is what measures the inclination and the direction on the y and x axis on the line. This is calculated by vertical rise and horizontal run. The slope is mainly used and plays a very important role in design and engineering, since it helps them to have a better and stronger structure.
Slope. Slope, also called gradient. M is what measures the inclination of the line of an equation. But how do we get the inclination of the line? The inclination of the line, that can be also defined as the vertical rise and the horizontal run, is given by the gradient or slope formula, which is the same. M equal y to the second power minus y to the first power over x to the second power minus x to the first power. This formula leaves us with the answer in this form: m equal vertical rise over horizontal run. We can find different types of slopes: positive, negative, zero, and undefined slope. To identify this, we can use keywords. A positive slope will always be going uphill, always less than 90 degrees. A negative slope will be going downhill, always being greater than 90 degrees. A zero slope will be presented as an horizontal line, being always at 180 degrees. An undefined slope will be located as a vertical line at 90 degrees.
But slopes do not end here. We can also find parallel and perpendicular slopes. Parallel lines are lines that will never intersect with each other in a plane and always keep a fixed distance between each other. These types of lines have equal slopes. For example, m1 equals m2, or m1 equals 1 over 2 and m2 equals 1 over 2. Perpendicular lines are lines that intersect at a 90-degree angle. These lines have negative reciprocals, like m1 equals negative 1 over m2, or m1 equals 1 over 2 and m2 equals negative 2.
At the top of the page, you can see the four types of slope. The first one being positive, the second one negative, third one having a value of 0, and the last one is considered an undefined slope. In the first example, it states to find the slope that passes through points negative 2 and 2 and negative 4 and 8. To solve this, we use the slope formula and took the x and y's needed. At the end, you subtract and it ends up giving you your result. In example 2, we had to find the slope of a line segment. In this exercise, it was simple as counting the number of squares the line takes over, either from the base to the top. You can observe there are 5 squares up and 5 squares in the base. Therefore, your answer is 5 over 5, that being simplified as 1. Moving on to example 3, we did the same as example 1, but had to find the value of variable x. Just as in number 1, we used the slope formula. We put 4 plus 2 on the top and 2 minus x, which is what we're trying to find. After solving with numbers we end up with negative 8x equals 10. We solve and it end up with 5/4.
Below that are two illustrations of what a parallel and a perpendicular slopes looks like. Parallel do not touch, and perpendiculars cross one another. Example 4 asks us to show if the given slopes are parallel to one another or not. In order to solve this, you solved for the slope of each of the set of the values. If they end up being the same, they're parallel. As you can see, m2 does not equal to m1, so the two lines are not parallel.